The cell potential is the potential difference between the anode and the cathode. When the anode and the cathode is connected, the current will not flow unless a salt bridge is set up. A salt bridge connects the two cells. When the electrons are extracted out from the anode, flow to the cathode, the ions in the solution move too. The current will go through the salt bridge. The electrode, salt bridge, and the wire or the load, if any, form a closed circuit. Current flow and the redox reaction occurs at the electrodes. The cell potential depends on the electrode potentials of the electrodes. In other words, the oxidizing or reducing strength of each half reaction, and the conditions under which the cell runs, for example, temperature, concentration, pressure, if gas is involved. For the known electrochemical cells, we don't have to measure the cell potential in the experiments. We can use the known electrode potential to predict the cell potential. Before we solve a problem, for example, we should remember the rules shown in the slide. If you reverse a half reaction, then change the sign of E naught. If you multiply a half reaction by n, E naught is unchanged. If you add two half reactions, then add the two E naught values.
Question: if we use the two half reaction below to compose an electrochemical cell, what is the cell potential? First, we should compare the reduction potential value of the two half reaction. Clearly, copper 1 plus copper 2 plus ion electrode has a reduction potential of positive 0.159 volts. It's higher than the other electrode potential. At the copper 1 plus copper 2 plus ion electrode, reduction reaction occurs, while the oxidation reaction occurs at the tin-ion electrode. Then we should reverse the reaction to tin lose its electrons, forms tin ion, and according to the rules we just learned, the sign of the potential value changed to positive. In addition, you should notice that there are only one electron in the reduction of copper ion. We have to double the reaction so that electrons can be cancelled in the addition of these two equations, and the E value does not change. We now add two equations and the two potentials. We have the cell potential is 0.159 plus 0.137 is 0.296 volts.
The sign of an E cell value has its meaning. If E cell is larger than 0, it indicates that the forward redox reaction is spontaneous. If E cell is less than 0, it means the reverse reaction is spontaneous. An external voltage or potential must be applied on to force the forward reaction to occur.